This is going to be our lecture video for August 28th, which is a Friday. So because it's a Friday, I'm going to try to keep this one shorter, and I'm going to focus on the classwork that was handed out in class. So I've got 3 problems from that, but do go ahead and get your notes out. This first problem is not from that worksheet, and I do want the few notes that I'm going to give you on this to go into your notebook. So here we've got an example problem. I want to make a couple points about this. So it says solve the following. It's a little weird to say solve inequalities because there is no one right answer, but we want to simplify this down to the point where we have a single variable on the left of an inequality symbol. It doesn't say solve and graph, but we're going to go ahead and graph this one too, just for practice. So here we go. I need to isolate that variable, so I'm going to subtract 4 from both sides. All right, I've got constants on both sides. I want to move them away from the variable. So now I've got negative 3x is greater than 15. And now I'm going to divide away the coefficient, divide by negative 3. And I get that x, I get an x on this side, and on this side I get a negative 5. But in the middle, it used to be a greater than symbol. It's going to switch to a less than symbol. All right, we've already talked about this in class, but now it's time to put this in our notes. We're going to write it out. If you draw an arrow right here, this is a very important rule about solving inequalities, is that if you ever multiply or divide by a negative, that word negative, then you must flip the inequality symbol. So whether it's a less than, greater than, less than or equal to, greater than or equal to, if we ever multiply or divide by a negative, then you must flip the inequality symbol. A common mistake would be something like this. Here I subtracted 4. Some people see that negative and think that it needs to flip here, but this was just a subtraction step. Subtraction doesn't count here. It's multiplying or dividing by a negative. It flips the polarity of the whole problem. And there's a way to double check this. This is something else we haven't talked about, which is how do we double check our solutions to inequalities. If we want to check our solution, we can't just plug in negative 5, because negative 5 technically isn't even a solution. And even if this was a less than or equal to, if we plug in negative 5, it's not going to tell us if this is facing the right direction. So we want to pick a number that's well underneath negative 5. We need to pick a number like negative 6. So we're going to plug in negative 6 to check, because negative 6 clearly satisfies this inequality here. Negative 6 is less than negative 5. All right, so it should work here. We should be able to plug in a negative 6 and get a true inequality. All right, but this isn't a definitive proof. It just shows us that we haven't done something like faced our inequality the wrong direction. You'd have to actually check a lot more values to know for sure that this is the correct inequality. So here's our algebraic solution. I'm plugging in negative 6 to check, and I should get a true inequality. So let's see. So 4, this is a negative 3 times a negative 6, so that becomes a positive 18. And now we get 22 is greater than 19. That is true. The alligator is eating the bigger number here. So this is a double check of sorts. It doesn't prove it entirely. So there we go. We got a note about what we do if we ever multiply or divide by a negative in our notes, and a way to double check these. Let's go ahead and practice graphing this real quick. I want to create a number line. The only really important number to put on that number line is negative 5, but I like to put a few surrounding numbers. Then I go to negative 5. I normally just draw an open circle and then decide if I'm going to fill it in. Here I'm going to leave it open. The variable's on the left, so I can use the trick that the inequality is pointing in the correct direction and draw an arrow going off to the left here. So there's our graph. Doesn't say solve and graph, but never hurts to add that in. Okay, so now some problems from that worksheet. We'll do 3 of them. We need to solve and graph this. So it's an OR type compound inequality, so I can just solve these separately. All right, starting with the first one, all I need to do is add 4 to both sides. I get that n is less than -2. I want to put a box around that. Work on the other side here. -2n is less than -14. Divide both sides by -2. Here's where that rule applies. We now have n is greater than +7. I want to put a box around both of these and then keep the same word in the middle. So n is less than -2 or n is greater than 7. We have 2 ways to have a valid answer, and or means it only has to satisfy one of these inequalities. All right, and now with these or types, they generally create 2 rays on our number line that diverge. We'll start with this first one. Open circle at -2, arrow going to the left. Open circle at 7, arrow going to the right. Now, what would happen if this point was to the left of this point? The arrows would overlap, but because this is an or, we would actually get just a solid line, and it would just be all real numbers is our solution. So that can happen. I'm not going to do that to you guys on a quiz or a test. If it's an or, it's going to end up looking like this with 2 rays and a gap in between them. Just know that they can overlap and you can get infinite solutions that way. All right, here we've got a compound inequality written as a single line. There's 2 things you can do with this. You can either split it up into 2 inequalities, or you can just do your inverse operations, but remember to do it to all 3 sides. I'm going to do that second thing. I'm going to do my inverse operations to all 3 sides. And my goal is to isolate that p in the middle. So that means getting rid of this +4. How do I get rid of a +4 with a -4? And then I do that inverse operation to all 3 sides. Now I've got 80 is less than or equal to -10p is less than or equal to 100. Got to get rid of that -10. That means dividing everything by -10. I could draw a single line like that if I want to. And then I would get -8, but I just divided by a negative, so this symbol flips, is greater than or equal to p, which is, this one flips as well, greater than or equal to -10. Now this is a fine way to write the answer, but it's not the best way because my bigger number's on the left. I prefer to see it this way, and if it's a multiple choice question, it's going to look like this with the -10 back on the left. But if I bring that -10 back to the left, all of the inequality symbols flip again because this inequality has to always be facing away from that -10. So I've got now -10 is less than or equal to p is less than or equal to -8. This is a better looking answer because the numbers go in numeric order. And with these single line inequalities, we want everything pointing to the left. Makes it a little bit easier to graph. I'm going to use closed circles at -10 and -8. This is going to be the line segment in between, where p is greater than the lower bound, but less than the higher bound. All right, one more. Here we've got an and, but not written as a single line, written as 2 separate inequalities. Here's something you can just add to your notes. With the and, we want to keep the overlap. And you could write off to the side if it's an or, we want to just keep everything. And that should make sense because if it's or, you can be one or the other, so we want to keep everywhere the line touches. But if it's and, you have to be both, so only the overlap is valid. Okay, let's solve this. 6n plus 2 is less than 7n minus 3. I'll just work with this one right now. I want to bring the variables to the left, so I'm going to subtract 7n from both sides. I know this gives me a negative, but I'm okay with that. Deal with it in a second here. Move the constants away from the variable. Subtracting 2 from both sides. Nothing flips, that's just a subtraction step. Now divide both sides by -1. Here's where things flip. N is less than +5. Box around that. All right, we'll deal with the other side now. -4 is less than n is less than 6n minus 4. Moving everything to the left. The reason I'm doing that is because I like using that trick where the inequality faces in the direction that the arrow goes. All right, negative 4 minus 7n, when I combine those like terms, is less than negative 4. Going to move the constants to the other side. Negative 7n is less than 0. Divide by negative 7. Just divided by a negative. What do we have to do? Flip the inequality. N is greater than 0. Box around that, and we want to keep that word and in between them. So if n is less than 5, that's an open circle here at 5, arrow coming this way. N is greater than 0, that's an open circle at 0, arrow coming this way. The region where they overlap is only that region in the middle, and that's how we get our line segment. So this is an open circle, this is an open circle.
Pardon the interruption.
Arrow in
Don
between.
Ramsey, can you please call 71512 or come to the main office? Thank you.
Hopefully Don Ramsey calls that number. Okay, I'm going to call that good for this. I'll toss one more question in after this for you to get credit for watching this lecture video. And have a good weekend. I'll see you in the Google Hangout.